21, 22, 23.
Question 21, 22, 23, all right. Okay, we'll go by pages first. So question 21. Now, because it says that it is the concentrated sodium chloride. So in a concentrated electrolyte, we said that the chloride is more preferred to be discharged over the hydroxides. Right, so you should have the chloride to be discharged at the anode. Agree? But then, don't you see that we are not using an inert electrode? We're actually using an active electrode. That is the copper electrode. So this copper electrode will get oxidized. All right, it will be oxidized rather than the concentrated chloride being discharged. So therefore, you should see that the copper anode will get depleted and there will be a decrease in the mass over the time. So that's why the graph shows a declining linear graph to represent the mass of the anode changes with time. For that.
Okay, so the chloride ions won't get discharged.
Now the chloride ions will only get discharged after the copper ions or the copper electrodes have been fully oxidized. Okay, but in the immediate reaction or immediate observation, you should see that the copper anode will get depleted over the time. Okay? And then what would you see at the copper cathode? At the copper cathode, you have the cation ion to be discharged, which is the hydrogen ions, and then you will get discharged to form the hydrogen gas. So these are the observations. And you know what happened at the end of the reaction? You will see that the electrolyte will become blue. Why? Because of the formation of the Cu2+ ions, which will get into the electrolyte. Okay. Now, question 22. For question 22, you have to work out the volume of the oxygen gas produced. Okay, let me show you the working. Right, so look at this, question 22. So at the anode, we will have the N ion to be discharged, that is the hydroxide ions, right, to produce oxygen gas and the water. Now on the other hand, because copper 2+ ions are more preferred to be discharged, at the cathode, we will have the Cu2+ discharged to form the copper matter. So after some time, they will have copper matter accumulated on the electrode, on the inert electrode or the inert cathode. And how much is the mass? 12 grams. So using this mass, find out the number of moles of the copper matter that is produced by dividing with the AR 64. And this number of moles is actually twice that number of moles of the oxygen. So how do I know what is the mole ratio? Now you have to learn how to write out the overall equation. This represents the overall reaction. So how to get this overall reaction here? There are 2 moles of electrons at the cathode, but there's 4 moles of electrons at the anode. So you're going to multiply this by 2 throughout. So you multiply this by 2 throughout, you will have the 2 Cu2+ and 4 OH- to give 2 H2O, 1 O2 and 2 Cu. So from here you can see the mole ratio between the copper is 2 is to 1 for oxygen and the copper matter. So that's why I'm going to divide by 2. And then to find the volume of oxygen gas, I multiply by 24 gm³. So for question 23, concentrated solution again, and they're using the inert electrode. So in the start, we add a few drops of the litmus solution. Now because this is an acidic solution, the litmus solution will turn red. Right, the limit solution will start off with the red color first, and now we're going to observe what is the color change, or if there's any color change or not. Right, so what are the ions that will be discharged at the anode and the cathode? We have the anode, which should be the chloride ions, and then at the cathode, it will be the H plus ions. So are the hydroxide ions being discharged? And what about the remaining H plus ions? Now don't forget, the H plus ions, there are two sources of H plus ions. H plus ions can come from the water molecules that are found in the hydrochloric acid. H plus ions can also come from the H plus from the hydrochloric acid itself. So the H plus ions that have been discharged comes from the hydroxide ion, comes from the hydrochloric acid ion. But the water molecule still remains as it is because there is no discharge of hydroxides nor the H plus ions from the water itself. So that is why the litmus solution remains the same. You understand? Got it? Any questions?
Can you explain again?
Yeah, so I was saying that there are two sources of the hydrogen ion. One comes from the water molecules in the hydrochloric acid, and the other one comes from the hydrochloric acid itself. Clear on this? Yeah, okay. So when the H plus ions are being discharged at the cathode, the amount of H plus ions that's removed, right, could be coming from the acid or the water. But it doesn't matter because in the end, the amount of H plus ions that remains will still be more than that of the hydroxide. See that? So that is why the H plus ions will cause the litmus to remain as red. See that? Because in the first place, the amount of H plus ions is actually more than that of hydroxide ions. And moreover, we have actually removed the chloride ions. So in the end, there will still be more H plus ions than hydroxide ions. That is why the litmus will still remain red. Got it? Sabrina, okay? On to the next page.
27.
27, all right. Okay, so this is a simple cell that connects the magnesium electrode and the iron electrode. So magnesium is more reactive than the iron. So you should expect the magnesium electrode to get oxidized. Alright, so the magnesium electrode will be at the positive terminal, the positive electrode. Sorry, the negative electrode. Okay, so magnesium is the negative electrode, which is the anode. So it gets oxidized to form the magnesium 2 plus ions. Okay, and then what about the iron electrode? So the iron electrode, we're going to look at which cation ion will be discharged from the electrolyte. So the electrolyte contains sodium ion and the H plus ion. So it definitely has the H plus ions to be discharged. So will the iron electrode take part in the reaction? No, definitely not. So that is why the mass remains constant. See that? So the half equations that happen in this simple cell will be Mg to form Mg2 plus. So let me write it out. Question 27. So at the anode, you have the magnesium being oxidized to magnesium 2 plus ions by losing 2 moles of electrons. And at the cathode, you will have the hydrogen ions to be reduced to form the hydrogen gas like this. Right, so you will see effervescence at the iron electrode, but the magnesium electrode will get depleted. Okay. Look at 27. Any more questions? What about the next page? This page, no other questions. Sabrina, is there any questions? Okay, yeah. Okay, what about 28 to 30? For me, question 29. Now, for question 29, they say that there is no decomposition product. So, which means that the substance Q is in its simplest form. So, it must be an element, because you know the elements cannot be broken down any further. And the only element that can conduct electricity must be the metal element. So, that's how we get B as the answer. Now, sugar solution is a covalent compound. Okay, so for question 33, you can see that we are using a mixture of the inert and the active electrodes. So inert electrode is used at the cathode, that's the negative terminal, and the active electrode is used at the anode, which is the positive terminal. So don't you think that this active electrode will get oxidized? Will get depleted slowly to form the Cu2 plus ions. So after some time, you will see that the Cu2 plus ions will be lingering in the electrolyte solution, causing it to turn blue. Because the formation of the Cu2 plus ions will cause the color to become blue. Alright? Yeah, so what about the bubbles at the colorless gas? So there'll be no more bubbles produced because we said that this will be oxidized already. The anode should have a decrease in the size, and there's definitely a visible change. So that's why C is the answer. Yep, 35. So decreases the most significantly. Why is it C? It's because at the anode, which N ion to be discharged? The hydroxide ion, right, will be discharged. You don't expect the nitrate ion to be discharged. So it's hydroxide discharged at the anode. Then what about the cathode? Ag+, because silver is below the hydrogen in the preferential discharge list. So what's left behind will be the H+ ion and the hydroxide ions. H+ ions and the nitrate ions, which will form the nitric acid. So that's why the H decreases.
Yeah.
Also, okay, so let's take a look at question 38. Now this rubidium is a group 1 metal, and you can see that the rubidium, the position of the rubidium in the periodic table is below the sodium. Now what do you see about group 1 metal reactivity? The reactivity decreases down the group, right? Okay, the reactivity increases down the group. Yeah, so this means that rubidium should be more reactive than the sodium. Okay, rubidium is more reactive than sodium. So do you think the rubidium ions can be discharged? Obviously not. Sodium can't be discharged because we talk about rubidium, which is more reactive. So the cation ion that will be discharged will be the H+ ion. Alright, so what about the N ion? Now because this is a concentrated solution, you should expect the iodide ions to be discharged. Just like in the chloride solution. In the concentrated chloride solution, the chloride ions are being discharged. Okay, so as a result, at the cathode, you will have effervescence of the hydrogen gas produced. Okay, that is at the cathode, which is negative electrode. And then at the positive electrode, you have the iodide ions to be discharged to form the iodine gas, which is the reddish brown solution. So that is why the answer for question 38 is C. Now I was saying that for this, some of this setup, right, they actually change the direction of the battery. So you have to look at it carefully. Just like in the previous example, you see this? This one, they actually draw the directions of the batteries, the polarities of the batteries differently. So check it out before you do the questions. Okay, yeah, so that's for question 38. Now next question 39. You want it 39? Yeah, okay, 39. So it says it's a false statement. Okay, let's write out the half equation that will happen in this setup. So what are the keywords? Electrolyte is zinc chloride, and then we have the Electrodes are the ion electrodes. So what is about the ion electrode? So the ion electrodes are considered to be the active electrode. So you should expect the iron electrode to get oxidized according to this half equation. Okay, and then at the cathode, what will be discharged? So we're going to look at the electrolyte, which is the zinc chloride. So in this zinc chloride, there are zinc 2 plus ions, H plus ions, Cl minus, and the OH minus ions. So at the cathode, it will be the OH plus, it will be the H plus ions that is more preferred to be discharged. So H plus to give the hydrogen gas. So what is remaining will be the zinc 2 plus hydroxide ions. Correct? And even the chloride ion. These are the remaining ions. They are found in the electrolyte. So that's why, if you look at the option here, A is definitely a wrong statement because the colorless gas of the hydrogen should be produced at the negative electrode. Okay, so let's look at the rest of the options. Why are they true? pH of the solution gradually increase. Yes, because we have removed the H plus ion, so the remaining hydroxide ions will give the alkaline properties. The solution will eventually turn green because of the production of the iron 2 ions, which comes from the oxidation of the iron electrode. So the iron 2 ions will get into the electrolyte, causing the solution to become green. Can and B, zinc ions are attracted to the negative electrodes. No, we said that only H plus ions are to be discharged. The zinc ions are not preferred to be discharged. Okay, but then if you read the question carefully, can you see that this is referring to the entire experiment? So even though H plus ions will be discharged first, but we said that the zinc ions will also be eventually discharged when it's nearing to the end of the reaction. You see that? Yeah, so that's why this statement is also true. Unless they change the questions and saying that what will be the immediate, right? The immediate observation, then this is not true because immediate observation you will have the hydrogen gas. Any more questions? Sabina, okay. Sabina, you got the answers or not? Because just now you came in a bit later. You have all the answers for this? Okay,
yeah, I got the answers.
Okay, sure. So no other questions from 4.3? Okay, so we will definitely be doing more revision questions as we move along. So if there's no questions on electrolysis, I'll close this worksheet and we shall look at the organic chemistry. Okay, so the last lesson we were looking at this worksheet 6.2. All right, worksheet 6.2, and we have also gone through the theory of the alkenes, the alkenes reaction. So do you remember we talked about alkenes undergoing the addition reaction? Because alkenes are unsaturated hydrocarbons. The CC double bond allows it to undergo addition reaction with hydrogen, and also the hydration. That's the water. All right, we also talk about the concept of isomerism. All right, the isomerism, and look at how isomerism can happen in the different types of the organic compounds. So with regards to the alkene reactions, do you have any more questions? If not today, we shall focus a bit more on isomerism because isomerism can be a bit confusing. No questions? No, okay. So later on, we'll try a few more questions on the reactions, but now let's take a look on isomerism. Let's switch the screen. Okay, so this is a pentane. All right, a pentane is an alkane with 5 carbon atoms. So it has a formula of C5H12, which follows the general formula of the pentane. So I didn't put in all the hydrogens, I'll leave that for you. Okay, but most importantly, when we study about the isomerism in the organic molecules, we have to look at the carbon backbone. We call it as the carbon backbone or the carbon main chain. All right, main chain as in MAINCHAIN or the backbone. All right, so there are different ways for a molecule to arrange themselves, and the purpose of undergoing isomerism is that the molecules want to gain higher stability, especially if the molecule gets bigger and bigger, like any hydrocarbons or any organic molecule. When it gets bigger, this carbon chain will become longer and longer, so it'll be very wobbly and very unstable. So they will tend to shorten the carbon chain and get it into different forms with higher stability. Alright, so that's why to define the isomers, we say that isomers are molecules with different structural formula, but they will still have the same chemical formula. Alright, so just like in the pentane, with a 5-carbon chain, they can shorten it to a 4-carbon chain, right, and get a branch out from here. So the 5th carbon, they put it as a branch that's attached to the main carbon chain. They can also shorten it to 3-carbon chain and put 2 branches, right, 2 branches in the 2nd carbon. Right, so that's the meaning of isomers. Right, okay, let me ask you a few questions. Now, if I were to arrange the carbon atoms in this manner, is this an isomer? Okay, so this is not an isomer. In fact, this is the same as this. Okay, they are the same. So why is it that they are the same? Because all the single bond can be rotated. You can actually rotate it up and get it to a straight chain. Okay, so actually needs a bit of time to visualize the structure because all this all this carbon chain, they are not flat on paper. In the actual fact, the organic molecules are 3-dimensional. All right, and let me show you an example. Okay, so you can see this is a 5-carbon atom. All right, I didn't put in all the hydrogen. So the black ones are the carbon atoms and the white ones are the hydrogen atoms. So in a straight chain, it goes like this, zigzag. Okay, but on the paper, we don't need to draw the zigzag chain, just have to draw a straight chain. How will the structure look like if it has this arrangement? It simply goes like this. This is how it looks like. Alright, so that's what I meant by this bond can be rotated. You can rotate it up and get it to a straight chain like this. Right? So that is why they are still referring to the same molecule and they cannot be known as an isomer. Okay, but then this and this two, this one and this one are isomers. It's because in order to get it to this structure, we have to break a bond. Like I break this bond, I get it to a 4. This one I put in 1 more carbon. Okay, I break this bond, I get it to a 4 carbon. Okay, then I attach the 5th carbon onto the 2nd molecule, the 2nd atom that goes like this. You see that? Yeah, so they are totally different structure because we need to break a bond in order to get it to this structure. Okay, then you may see that how come this one is considered to be the 2nd carbon atom? Because you can split the whole molecule and it turns it to this. Isn't it the same as this structure? So that's how it works. Alright? Okay, so you need a bit of time to identify which one is isomer, which is not isomer. First of all, you have to check whether the chemical formula are the same. If the chemical formula are the same, then you can check on their structural formula. If the chemical formula are totally different, you don't even have to talk about isomerism. Alright? Okay, then what about this structure? This structure looks like that. So this is the structure. It's like a tetrahedral structure. Okay, so these two carbon atoms, the one at the top and the bottom, are referring to this and this. Okay, this is the straight chain. Okay? Yeah, and they are totally different structure from the straight chain alkane. Any questions? Yeah, okay, so after we understood the concept of isomerism, then we have to understand that actually every organic compound, they exist, they have an isomerism. Alright, not just the alkane itself, even alkene, they can also have isomers. Alright, but the isomers of alkenes will be a little special. For example, the butene, C4H8, this is known as a butene. Right, so this is one isomer. The other isomers about the alkene is this. Alright, so that means for the isomerism in alkenes, right, we not only look at the long carbon chain. It's a little laggy, can you hear me or not? Can, okay, good. Alright, so we are not only looking at the carbon chain itself, but we also look at the position of the CC double bond. Can you see that this CC double bond, which is the functional group, is attached on the first and the second carbon, whereas this CC double bond is attached to the second and the third carbon atoms. Yeah, so they are considered to be different. The main reason is because double bond cannot be broken at all. So a double bond cannot be rotated. Okay, let me show you. Look at this. This is a double bond. They have been restricted by the second covalent bond, so cannot be rotated. You can expect this to rotate it, and just like how the alkane can be so flexible. Yeah, so in a double bond, no rotation, we can only shorten the carbon chain. Right, but if they are single bond in the alkene, they can still be rotated. Right, so we will look at the position of the functional group. Or another way is we can shorten the carbon chain. From 4 carbon chain becomes 3 carbon chain, and then you do a branch. Alright, so these are all the isomers of the alkene, which is butane, C4H8. Yeah? Okay, then next is we're going to learn how to name the isomers. How do we name these isomers? So let's start off with the pentane. We know that this is the normal pentane, so we just call it pentane. But what about this? If it shortens the carbon chain, then we have to name the longest carbon chain first. So here you can see that the longest carbon chain is referring to this 4 carbon atoms. They are interlocking with one another. So that gives a 4 carbon alkene, which we call this as a butane. Right, so this is known as something butane. Now after we have named the base compound, we must name the branch. So you can see this is the branch. Right, now the branch will follow a general formula. So branch is also known as the alkyl. So what is the general formula? CnH2n plus 1. Okay, CnH2n plus 1. If n is equals to 1, it's known as the methyl. If n equals to 2, it's known as the ethyl. Right? So here I have a branch that only contains 1 carbon, so it's called methyl. So it's a methyl butane. Now besides naming the branch, you must also give the position of the branch on the carbon chain. Can you see this branch is attached to the second carbon? So we call this as 2-methyl butane. So that is the rule of naming the molecules, the organic molecules. Not just for isomers, whenever you are given an organic compound, you have to name the organic molecules in this way. Okay, another example, this one. So what is the longest carbon chain? The continuous carbon chain is a 3 carbon chain. This one. You can also say that it is the vertical one, can, they are the same, because no matter how you rotate, it will all be symmetrical for this molecule. Okay, so this 3-carbon chain is made up of a CC single bond, so it will be an alkene. And what is a 3-carbon alkene? That is a propane. So it's Propane. So propane is the basic name. Okay, then you must name the branches. All right, so here the branches, there are 2 separate branches. Okay, all attached to the same carbon in the carbon chain. So each branch has 1 carbon, which is known as a methyl. See, 1 carbon chain, 1 carbon branch is a methyl. But there are 2 of them, so we call it a dimethyl. Okay, dimethyl. Understand? Then after that, we're going to give the position of the branch. So the branch is attached to the second carbon, and there are 2 of them, so we call it a 2,2 dimethylpropane. So it's 2,2 because the 2 carbons are attached onto the same carbon atom, the second carbon atom, so it's 2,2. Okay, so when will we use the word ethyl? Now when we use the word ethyl, if the branches has 2 carbon atoms here joined together, like in this structure here. So where is the longest carbon chain? The longest carbon chain is actually a 4-carbon chain. Sorry, a 5-carbon chain. Or you may think that this one can also be the longest continuous chain. But then this one only got 4. 1, 2, 3, 4. But if you look at this chain here, it has 5 carbon chains. So that's what we meant by longest continuous carbon chain. So this is 5. So the base material is the what? Pentane. Right, so pentane. You see this is a pentane. Right? So next, we got to name the branch. See, this branch has 2 carbons that are interlocking with one another. So a 2-carbon branch is known as an ethyl. Right? So this is the ethyl pentane. Now we not only have to name the branch, we must also give a position. So it's on the second carbon, so it's called 2-ethyl pentane. Understand this? Okay, so what about this structure? Now, is this structure the same as this, or they are different structural formula? Are they the same or are they different? Let's see.
Same.
Yeah, so are they same or different?
Same.
Same, right? Sabrina, you know why is it the same? Because this structure, you can split it 360, 180 degrees, you will get through to this structure. So they are the same. Right? And when you name, if let's say you're given this, right, you don't think that this is actually a 4-ethyl pentane. You must name it from right to left. Okay, because when you name from right to left, the number will be a lower number priority, which is 2-ethyl pentane. So always name it with the lower number as the priority. All right. Okay, so these are the examples on how you can name the isomers of any organic molecules of the alkanes. Okay, now what about naming this isomers from the family of the alkene? So this is butene. Now we call it as but1A. You see the 1 is put in between the letters. Okay, then this is but2A. So why is it called but2A and but1A? It's because of the position of the CC double bond. For the first molecule, this CC double bond is put on the first and the second carbon, whereas the second one, the CC molecules are put on, the CC double bond are put on the second and the third molecule. So 1, 2, 2, 3. Understand? So always name the lower priority. So we don't call this as build 2 in and this one build 3 in. Okay, we follow the lowest number first. Then what about this? Now this same naming pattern, look out for the longest carbon chain. Longest carbon chain will be a 3-carbon chain. And because it is an alkene, a 3-carbon chain is known as a pro, so it's propene. All right, then after that, you're going to name the branch. So name the branch. Now the branch has how many carbon atoms? Only 1 carbon atom, which is methyl. So it's known as a methyl propene. But then which position is the methyl in? It's on the second carbon, so it's called 2-methyl propene. All right. Okay, then there was also a student who asked, how come sometimes I put a dash, then sometimes I put comma, why sometimes I don't put dash? Now, whether you want to put dashes or not, you decide for yourself. If you don't want to put dashes, you want to write the whole thing in letters, also can. But some people, they have a habit of putting dashes is to separate the words and be able to read them more clearly. All right? And if you look at things like maybe the detergent, shampoo, they have all the ingredients, right? They are all made of organic molecules, organic compounds. You see their names are like that, very long names. They also put dashes. And they put commas as well. Commas are more for separating the numbers. Yeah. And then usually I will put a dash after the number, as in between the numbers and the letters, so that it's easier to read. It's also clearer. Okay? So these are the rules of naming the organic compounds. Any other questions? Okay, then the other thing is, the isomerism is not just happening only in the hydrocarbons. You can also have isomerism in other organic compounds like alcohol, carboxylic acid, esters, and many, many more. All right, so the idea about isomerism is just a natural behavior for the organic molecules to gain a higher stability. All right, so the definition never says that isomers must come from the same family. You can also have isomers from the different functional groups. For example, this one. So just now we talked about butene, right? See this butene? We have the 3 examples of the isomers that come from the family of the alkene. But then you can also have another isomer of butane, which does not belong to the family of alkene. You look at this. This is also a C4H8. But this is not an alkene. This is actually an alkane. Now we name this compound as cyclobutane. All right, so what do you mean by cyclo? Cyclo is a name given to any cyclic structure. In organic, they actually can form this kind of cyclic structure. That means the functional group will link up with one another, all the carbons will link up with one another to form a ring structure. All right, so this cyclobutane, although it does not follow the general formula of the alkane, but its chemical properties will still be the same as the alkane. Understand? All right, so in other words, the cyclobutane can react with a halogen under the presence of the UV light to form a chloro-substituted product. It means one of the chlorine will be able to replace the hydrogen to form this chlorocyclobutane and then a byproduct. Yeah, that's how it works. All right? Yeah, so these are the important things that you have to take note. Now, can an alkene take on a cyclic structure? Yes. Actually, all types of hydrocarbons can take on a cyclic structure. So how will a cyclic alkene look like? Let's say we have this. So this is known as a cyclohexene. Why is it a hex? Because there are 6 carbon atoms. And why is it a hexene? Because there's a C double bond. And it's a ring structure that takes on a hexagonal shape. Okay? So will cyclohexene undergo the addition reaction? Obviously it will. Alright, so let's say when it reacts with water, H2O, then it is only this part of the C double bond that will undergo the hydration process. You remember what are the conditions? Okay, haven't memorized, right? 60 atm pressure, temperature 300 degrees Celsius, and we're going to use the phosphoric acid as a catalyst. So what will be the product? The product will be this. We add a H and an OH on these 2 carbon atoms. Then the rest will remain the same. And you can see no more CC double bond from an unsaturated hydrocarbon will become a saturated hydrocarbon. Understand? Any questions? Okay, so if there's no questions, we're going to try a few examples from the worksheet 6.2 on isomerism. Can you give a try for question 4 and then question 15? Right, 4 and 15. Okay, let's try it first, 4 and 15. Okay, let's run through. So what is the answer for question 4? So if you see that they are the same compound, if they are the same, do you think they are isomers or not isomers? What do you think? Valerie and Sabina? Are they the same or are they isomers or are they not isomers? Valerie?
Isomers.
Not
So
isomers.
not isomers, right? Yeah, okay, they are not isomers. If they are the same, they are not isomers. They must be different, then they can be isomers. Right, so did you have 2, 3, and 5? Yeah, okay, so 2, 3, and 5 are exactly the same. You look at the CC double bond, they can be rotated. So you see here, or maybe you can use this bond here can be rotated upwards, and it gets you to this structure, and also this structure. So you rotate this, and then you flip, you will get it to 2. And for this one, you flip downwards, you get 3. So the isomers, the ones that are different will be 1, 4, and the set of 2, 3, 5. Okay? And okay, let's look at question 15. So which of these compounds are isomers of each other?
D.
Sorry?
D, P, Q, and R.
Oh, P and R, is it?
P, Q, and
Oh,
R.
P and R, okay, they are isomers of each other. Yes, P and R are actually isomers. But actually, P also isomers. Remember, isomers may not need to be the same functional group. They can also come from different functional groups. Alright, so if you count the total number of carbon, hydrogen, and the oxygen atom, you will have this formula, which is C3H8O. Right, all these 3 compounds have C3H8O. It's just that their functional group are different. You see, this functional group is an OH. This one also has an OH. So these 2, they belong to the same family, which is the alcohol. Alright, but then the first molecule, it comes from a functional group called an ether. Right, it comes from a functional group of ether. So this QR belongs to the family of alcohol, but this one belongs to the family of the ether. All these different functional groups, but all of them are isomers of one another. Understand this concept? Okay, yeah. Now in the next chapter, you're going to learn about the alcohol. Alcohol has the general formula of CnH2n plus 1 OH. Right, CnH2n plus 1 OH. The OH is the functional group that controls the chemical properties of the alcohol. So what do we call this OH group? Just like the CC double bond is called an unsaturated bond, CC single bond is saturated bond. OH is known as the hydroxyl functional group. Okay, any questions? Okay, very good.
So the answer is D, right?
Yeah, D for donkey. All of them are instruments. Okay, since you are fine with this question, let me clear the writings first. Now, for the remaining time, I would like you to try question 1. Question 1, 2. I think 3 we done last week. You can try 1 and 2. Or maybe you fill in the blanks for the remaining questions up to question 10. Is it okay? Yeah, up to the question 10. Just a few more to go.
The most question.
Oh, the number of moles. Okay. All right, so for question 8, now first of all, we're going to recognize whether this hydrocarbon is an alkane or alkene. Because remember we said that an alkane can only react with a halogen, right? But in the question it's talking about reaction with hydrogen, so it must be an alkene. Okay, so look out for the option and then cross out those that are not alkenes. You know how to check, right? Using a general formula. So alkenes are C. It's only C. The rest are all alkenes. Got it? So actually the mole here is redundant. They're just there to confuse you. Alright, sometimes the harder questions, they can give you, they can tell you that this is alkene and then you need to do some calculation using the mole concept formula to work out. Alright? Okay, then question 10. For question 10, in each of the hydrocarbons, you have to write out the equation. Alright, so if you look at the hydrocarbon, which is, let me see, this D-C7H16. Okay, how do you balance the equation? Okay, let's write out this equation first. C7H16. So during a combustion reaction, it will produce the carbon dioxide and the water, C7H16. So then we balance the equation, 7 here, and then this is 8. So how many oxygen are there all together? 14 plus 8 is 22. So we'll put 11 on the oxygen. So can't you see that the option 10 tallies to all this mole ratio for the carbon dioxide and the water? Got it?
So you must write the equation for every.
Oh yes, you have to write the equation. After writing the equation, we can use the concept called remember we talked about volume of gases proportional to the mole ratio. Yeah, so since these are all gases, the number of moles will also be proportional to the volume of the gases. Right. What about the questions in the earlier part?
7.
No questions.
7.
Oh, 7. Okay. So members of the same homologous series is correct. Definitely B, they will undergo similar chemical reactions. They cannot have the same empirical formula. Neither will they have the same melting point, because we know that in a homologous series, the melting point of the hydrocarbon should increase down the group due to the increasing number of carbon and the hydrogen atoms.
How about A?
How about what?
A.
A. They cannot have the same empirical formula. You look at alkanes, CH4, C2H6. Can we reduce CH4 further? We can't. CH4 is the simplest formula. But we can reduce C2H6, which will get to CH3. But they do not have the same empirical formula. Only alkenes will have the same empirical formula, which is CH2. But it doesn't mean that all families or all the homologous series will have the same empirical formula. Understand? Any other questions? Okay, good. All right, so if you have the time, you can try and finish up the questions 11 to 20, the remaining questions. Now, next week, I will want to close up the topic on alkenes by going through the addition polymerization, and then we will be moving on to some introduction on the alcohol.